this as a definite radical rational function. And in order to solve this, we have to consider the domain of the function. And the domain of the function is determined by the behavior of the denominator. So in order for me to identify the nature of the denominator, I will use the cosine approach. Now, using the cosine approach, which is the trig approach, first consider a right angle triangle, so which I've drawn in the sketch down here. So this is a theta, the angle, let's say we've been given a theta, okay, theta, and we have the y coordinate and the x. So we have here the hypotenuse, which will be 1. So in solving the y, we get this here. Okay, you can do the substitution. We know the Pythagoras theorem approach. All right, so in this, if we decide to make to connect the x and the 1, okay, we'll have cos theta equals x. Okay, so what we do now is wherever we see x, okay, we put this there, and that is what I'll be using. So that's the cosine substitution that I'll be using. So we have the integral of x squared on the square root of 1 minus x squared. The x, okay, will be equals to the integral of x squared all on the square root of 1 minus, so we have now substituted the x for this. So we have substitute this cos square theta, okay. Now the dx, okay, so we can also change the dx as well, so by differentiating this. So when you differentiate cos theta, you get negative sign, so you have dx negative sine theta in terms of theta. So now making the x the subject, we'll be having, so we're having negative sine theta times d theta. So you have negative sine theta d theta. So that's what we have there. So we further break this down, simplifying this here, okay. And remember also, we can also simplify this as well, okay. We'll keep the values of 0, 1. We'll later introduce it later. I will later introduce it, okay. Or we can even do it right now. Remember, we have 1, okay. X, we have x should be 1, okay. The limit is from 0 to 1, so we look for the limit of in terms of theta. So when x is 1, theta will be what? So we have cos theta when x equals to 1. So that will give us theta equals cos inverse of 1, which will be equals to 0 degrees. We do the same thing for when x equals 0. Okay, so we'll be having cos theta equals 0. So theta will be equals to cos inverse of 0 will be 90 degrees. So we have here 0 degrees and here 90 degrees. Okay, good. So so what we do now, it's we simplify this. We have here, so we have this will be equals to the integral from 90 degrees to 0 degrees. Then x, remember it's cos theta, so we have cos square theta on this. This is an identity, okay? We can use the identity sine square theta plus cos square theta equals 1. Okay, so making sine the subject, you get this here. Okay, so you get sine equals 1 minus cos square theta all in square root, so that's equals to this. So this can be substituted. So we have sine here, sine theta, and here we still have a negative sine theta d theta. Okay, so we can further simplify this here. This we have here. We can further simplify this. Okay, so this will give us from 0 degrees to 90 degrees. Okay, this and this, okay, cancel, so we get negative cos square theta d theta. So we break this one down further. We break this one down. Okay, now to solve this one, we can't integrate this straight away unless we apply the trig identity as well. Okay, but remember that cos 2 theta equals cos square theta minus sine square theta from the cos identity. So we simplify this one, okay, to get this in this one form. So what we do is we try to express also this one too in terms of something which it can easily be used, something that can easily be used to be integrated or differentiated. Okay, so we'll go back to our identity here, this identity here, and do the substitution. So here, so we know that sine square theta is the same thing as, so we have cos 2 theta equals cos square theta minus here, so we have this will be 1 minus cos square theta. So you have something like this. So you can further break this one down. Okay, so you have cos 2 theta equals, so here, so cos, open the bracket here, so we can do it straight away. So you have 2 cos square theta here, this will be minus 1. Okay, so simplifying all, you have cos 2 theta equals, okay, so we can make it straight, so plus 1 equals, this will be cos square theta all on 2. So we have this. Okay, so this, in place of this square, in place of the cos square theta, we can put all this here. So this is what we'll use to do the integral here. Okay, so having this implies the integral from 0 90 degrees, so there's always negative, there's a negative, minus is there, so we put this equals. Okay, so we can now also do the simplification, continue with that. Okay, so you can now integrate. Okay, so you can integrate it separately. So you know that minus, you can bring the minus out. Okay, minus, so you have brackets open. Okay, So we do this, we have cos 2 theta. Okay, all on 2, then plus, okay, same thing, half here, so we can separate it here. Okay, then d theta. So here too we bring the limits, so we can integrate separately. Okay, so we have now, this will be equals to, so we take this now separately. Okay, so we have negative, the first one. So when you differentiate this one here, okay, you'll be getting sine. Okay, so we have cos theta. So you have sine, but there's already half there, so you have half, then you have sine 2 theta, and you integrate this one, you get sine, you integrate, you get sine, so you get sine 2 theta, and you differentiate what is inside, okay, then you get times half, okay, because you get 2, so you get times half. I think you're familiar with the integration by substitution, so you understand what I just did right now. So you do the same thing for this also. This is a constant, so when you integrate that, you'll be getting theta, so you have half of theta, okay, and all should be evaluated from 90 degrees to 0 degrees. Okay, so we can now insert the values for each of them. So you do this left part, and you also do this right part. Okay, so you know that for this one, when you insert the 90 degrees, so let's go up here. So when you insert the 90 degrees, so you have this will be equals to negative, bracket open, so you have 1 on 2, so 1 on 2, so 1 on 2, 1 on 2, sine 2 theta, so sine 2 theta, so you have first put insert the 0, so you get sine 0, sine 0 degrees, minus half of, so the half times half will give us 4, so here, so half times half will give us 1 on 4, so you have 1 on 4 here, so 1 on 4, so minus the same thing, half of sine 90 degrees. Okay, then we did the same thing for the half, so plus half theta, plus half of the same thing, 90 degrees, so it will be 0 degrees. Okay, then minus half of 90 degrees. Okay, and we close. So the same thing here, so minus sine 0 gives us, this is 2 times 0, so that's 2 times 2 times 90, okay, here supposed to be 2, so 2 times 90, 2 times 90 degrees, that will be 180 degrees. So here sine 0 gives us 0, okay, so everything here goes to 0. Here to the same thing, sine of 180 degrees gives us also 0, so everything also goes to 0. So here 0 0, so we have 0 0 forward side, and this is half of 0 degrees give us what? 0, and here it gives us 1 f. So you have half of 0 degrees is 0, and here we have 1 negative 1 on 2, so here 45, so negative minus 45 degrees. So when you solve, you get positive 45 degrees. So positive 45 degrees is the same thing as pi on 4. So that is it. Thank you.